Isoleucine is a structural isomer of leucine, and it's number 10 on the list. If I sort by hydropathy index, isoleucine is the highest positive value in the list, meaning it's the most hydrophobic side chain of the amino acids. If you remember the branched chain amino acids, which I'll get to later, you'll see all three of them are the top hydrophobic amino acids: isoleucine, valine, and leucine. So I'll go ahead and draw it here. You have your alpha carbon carboxylic acid group on the side here, and amino group on the side here. And with isoleucine, you're going to have 4 different carbons on the side chain. If you remember leucine, you can get leucine just by swapping these molecules here. Let me, I don't want to call them side chains, but I'm not sure the correct word for them. But we'll just move these a little further away. And if I were to delete this bond here, which I'll have to put the hydrogen back, and delete this bond here. Now if I were to swap them, that is the change that gives you leucine. So you can see that we didn't lose any atoms, we just rearranged them, so it's a structural isomer. Let me just search for it to bring up the actual isoleucine molecule, left-handed again. Right here is the alpha carbon amino group, carboxylic acid group, or carboxyl group. And then here's the side chain of 4 carbons. And I've already searched, I already searched for it, but you can see it here on the right side. And you can tell that it's very hydrophobic. It's just this hydrocarbon side chain with the branch coming early, and then you have this 2-carbon unbranched hydrocarbon here at the end. So here's all the amino acids. Down here is the hydrophobic section. We've covered these first 4: alanine, valine, isoleucine, and leucine. And so you can see that they're all 4 just various arrangements of that hydrophobic hydrocarbon side chain. The abbreviation is ILE. And it's not the first 3 letters like usual, but since iso is a prefix, the symbol is ILE, which makes it a little bit more specific. And the 1 letter is I. It is the only amino acid that's coded by 3 codons. The rest are 1, 2, 4, or 6 codons. It is essential. It is an essential amino acid. So you need to have it in your diet. There are ways for plants and microorganisms or prokaryotes to make it, but humans cannot. But we do break it down in catabolism to make other components. So here's the branch side chain: leucine, isoleucine, valine. You can see isoleucine here. And as far as catabolism, isoleucine is listed as both glucogenic and ketogenic. So it can be broken down in pathways that make glucose or various ketone molecules. The last thing I was going to mention is since it is hydrophobic, when it's in a protein, it'll be usually inside of inside the protein towards the middle, in some hydrophobic pocket inside the protein. I'm thinking of more like a globular protein, or it would be on the outside of the protein in some hydrophobic environment, like in a lipid bilayer membrane.